carry out an activity. Take a ball in your hand and allow it to bounce on the floor. Each time ball bounces and its height gets cut down by half. If the ball's first height is 4 feet, the next time it bounces, its highest bounce will be at 2 feet. After that, 1 feet and so on until the ball stops bouncing. Well, have you observed the numbers obtained in this case? 4, 2, 1, etc. Are these numbers following any specific pattern? The answer to this is yes. These numbers are following geometric progression. Now, the question arises, what is geometric progression? When a sequence has a constant ratio between its successive terms, it is called a geometric progression. And the constant term is called the common ratio. And it is represented by the letter R. Geometric progression is often abbreviated as GP. Now, let's look at some examples. Consider the sequence 2, 6, 18, 54. Here, each term in the sequence is 3 times the previous term. So, the common ratio in this case is 3. Now, another sequence 1, minus 2, 4, minus 8. Each term is minus 2 times the previous term. Just see. So, here the common ratio in this case is minus 2. Now, let us write down a general geometric progression using algebra. We shall take A as the first term of the sequence and R as the common ratio. Then, the general geometric progression can be expressed as A, AR, AR square, AR cube and so on. From this, we can write the nth term of the GP. It is A into R raised to n minus 1, where the power n minus 1 is always 1 less than the position n of the term in the sequence. And the nth term of the GP is denoted as AN. Now, let us find out the sum to n terms of a GP. Suppose that we want to find the sum of first n terms of a geometric progression. What we get is Sn is equal to A plus AR square plus AR cube and so on up to AR raised to n minus 1. And we denote this equation as equation number 1. This is actually called geometric series. Now, to find the sum, we multiply both sides of the equation by R. So, equation 1 by R, what we get? The resulting equation will be R into Sn is equal to AR plus AR square plus AR cube plus AR raised to 4 up to AR raised to n. And denote this equation as equation number 2. Now, we have to subtract the equation number 2 from equation number 1 and we obtain Sn minus R Sn is equal to A minus A into R raised to n. That is, Sn into 1 minus R is equal to A into 1 minus R raised to n. From this, we get Sn is equal to A into 1 minus R raised to n divided by 1 minus R, where R not equal to 1. Or again we can write Sn is equal to A into R raised to n minus 1 by R minus 1, where R not equal to 1. Here note that the quantity A by 1 minus R is called sum to infinity and is represented by yes, infinity. Let's see one question. Find the sum to 6 terms of the geometric series 2 plus 6 plus 18 plus 54 and so on, where there are n terms in the series. So, n is equal to 6. So, for this particular series, we have A equal to 2, the first term, and what is the common ratio? R equal to 3 and n is equal to 6 as there are 6 terms. So, Sn is equal to a into 1 minus r raised to n by 1 minus r. Now putting the values of a, r and n in this equation, and we get Sn is equal to, that is S6th term. X6 is equal to 2 into 1 minus 3 raised to 6 by 1 minus 3, which is equal to 2 into 1 minus 729 divided by minus 2. And on solving, we get the final answer as 728. So the sum to 6 terms of a given JP is 728. Now, let's look at another example. How many terms are there in the geometric progression 2, 4, 8, etc. up to 128? So, in this particular sequence, as per the given data, we can write a equal to 2, r equal to 2, and n is equal to 128, which is the nth term. Now, the formula for nth term of a GP is given by an is equal to a into r raised to n minus 1. Substitute the values, we get 128 is equal to 2 into 2 raised to 2 n minus 1. From there, we get 64 is equal to 2 raised to n minus 1. Again, 64 can be written as 2 raised to 6. Now, as the base are same, we can compare the powers. So, from there, we get 6 is equal to n minus 1 or n is equal to 7. So, there are 7 terms in this particular geometric progression. Right? Now, let's look at a basic property of GP. If each term of a GP is multiplied or divided by some fixed non-zero number, then the resulting sequence is also a GP. So far, we have been discussing about the basic properties of geometric mean. Now, it's time for us to understand about geometric mean. The geometric mean of two positive numbers a and b is the number square root of ab, and the geometric mean is abbreviated as GM. For example, the geometric mean of 4 and 9 is 6. How? Root of 36, which is equal to 6. Here we observe that the three numbers 4, 6, 9 are the consecutive terms of a GP with the common ratio 3 by 2. This leads to a generalization of the concept of geometric mean of two numbers. Given any two positive numbers a and b, we can insert as many numbers as we like between them to make the resulting sequence in a GP. We can insert n numbers g1, g2 up to gn between a and b such that a, g1, g2, gn, b forms a GP. Now we have to establish a relationship between AM and GM. Consider two positive real numbers a and b. Then AM is given by a plus b by 2. And what is GM? GM is the root of AB. Now we have to subtract AM from GM and we get a plus b by 2 minus root of AB, which is equal to a plus b minus 2 root AB by 2. And on rearranging, we get it as root a minus root b the whole square divided by 2, which is greater than or equal to 0. So from this, we obtain the relationship that AM is always greater than or equal to GM. Alright? If AM and GM of two positive numbers a and b are 15 and 9 respectively, find the numbers. How to find? We know AM is equal to a plus b by 2, which is equal to 15. Let it be the equation number 1. Now GM is root of AB, which is equal to 9. Let it be the equation number 2. Now from equation number 1 and equation number 2, we get a plus b is equal to 30 and ab equal to 81. And we know a minus b the whole square is equal to a plus b the whole square minus 4ab. Now putting the values in this equation, we get a minus b the whole square is equal to 900 minus 324 and we get it as 576. That is a minus b is equal to 24. And on solving, a plus b is equal to 30 and a minus b is equal to 24. We get the values of a as 27 and b as 3. So far, we have discussed all the basic concepts related to GP and its properties. Geometric progressions are used throughout mathematics and they have many important applications in physics, engineering, biology, economics, computer science, queuing theory, and finance. We will deal with another special type of series in the upcoming video, and here we have the summary of our entire concept.
Manorama Horizon. Learning made simple.